mechanisms for integrating real data into search game simulations, and application to winter health service pressures and preventative policies. In this work, we use search games, which are a type of game theoretic model, to model the pressures felt by the families in a given population during the winter months, and how this ultimately affects health and in turn puts pressure on health services. We identified that for application areas like this, there's a need to use real data with these search game simulations in order to bridge the gap between abstract models and the real world. I have no disclosures. After this session, a learner should be able to understand how search game models can enable us to explore complex public health issues such as service pressures, and importantly be able to identify the types of data that we need when doing this to ensure that we are modeling and simulating accurately. I want to start by introducing the notion of a search game. So here we see an example, a simple example of a search game. So within this game, there are 3 objects positioned in a search space, in this case, a graph. And in this specific example, we have objects positioned at nodes v5, v4, and v3. In this space, we imagine there exists what we call a seeking agent, an entity that can move between the nodes in the graph with the view to locating these objects. And each movement made by this entity has a cost associated with it, in this case 10. And the question or the challenge in the search game is how does this seeking agent move between the nodes to find all the objects needed in the cheapest way? And we can see in this simple example that the best strategy or the best way for a seeker to move is to go anti-clockwise if they're starting at v6, and they will find the objects that they need within 3 hops with a total cost of 30. Separately, we can think about the concept of winter pressures. So it's true that around the world, during the winter months, families need to acquire resources such as heat and not exceed their financial means in doing so. And it's worth saying that the impact of not getting these resources is typically for families on the health within those families, specifically child health, and specific conditions like respiratory or mental health conditions can really be exacerbated if children are living in cold and damp conditions. The task of acquiring these resources becomes much harder during a cost of living crisis when the finances available are already stretched. Let's combine these 2 concepts together as a part of them, or this is what we did as a part of the methods for our study. And what we did was we really viewed seekers in a search game as an abstraction of families in a winter pressures scenario. So what we can see is we can actually configure our search game to represent the challenging resource-based environment that families face in the winter months. So we could imagine the game that we saw at the beginning, this simple requiring 3 hops in order for the seeker to find their resources or hidden objects, as representing the non-winter months, because this is a relatively straightforward resource collection task. Whereas we can imagine this second game here on the right, where resources are hidden at the edges of the graph, thus requiring the seeker to make many more hops with a much higher cost. We can see this as reflecting the winter months, where acquiring resources is much more of a challenge. We can take this idea further and actually try and capture more variables relating to winter pressures. We can, for example, capture or use the strategies that a seeker has in a game. So, like we've talked about, how a seeker should move between nodes to represent different health conditions. We can introduce this notion of game success, so correlating whether a seeker has found all the hidden objects with a cost that's less than the total edge costs in a graph, correlating that with what we call payoff, so the reward in the game. And again, we can use this to model the presence or absence of health conditions. If there is an impact on payoff, we could say that there are conditions present. If there isn't, we could say there aren't conditions. And finally, we can introduce this notion of what we call gas, which is a budget provided to each player so that the cost of moving from node to node doesn't directly impact their payoff, but instead goes against this gas level. It offsets traversal costs. And we can see this quite naturally mirroring things like socioeconomic condition. So players with a higher amount of gas, for example, we could use to represent higher socioeconomic condition. A natural question now is, why do we want to do this? Why do we want to model winter pressures in this way using a search game formalism? And the answer is because we can also model and thus evaluate ways to try and help families during the winter months, specifically mechanisms put in place by governments in order to help families. We call these government interventions, and we look at three specific examples here. The first is issuing advice. So, for example, mechanisms to heat a home that don't have a financial element to them. And we can reflect this in our game using high performing search strategies to reflect taking that advice. Next, we can model support payments in the UK. So, for example, household support funds. We can model this relatively naturally as giving our seekers extra gas. And finally, we can model increasing vaccine eligibility. So, for example, again in the UK context, rolling out or increasing age-based eligibility for free child flu vaccinations. And we can again model this as reducing the impact of unsuccessful games on payoff, because effectively when you vaccinate, you are to a degree emulating the absence of a condition. Note that these interventions are all designed to improve health, which in turn reduces inequalities and in turn still reduces pressures on health services. So the focus really here is on reducing pressures on health services. We immediately hit a snag in terms of the level of abstraction we find in this model. It's true that in some ways it's hard at a high level of abstraction with us that a search game provides to really model the nuances of the real world, the real nuances of the winter pressures use case, for example. In other words, any results obtained from the search game model are going to require extensive validation before we can use them to really evaluate the real world. One way we can bridge this gap, one natural way to bridge this gap, is to actually bring real data from the world into our model and thus make or attempt to reduce the validation required for any insight that we gain. And this is really the crux of our work here. What we've identified is 4 key types of data that can be used to configure a search game and thus allow, like we say, to more closely model the winter pressures use case and almost provide a level of pre-validation to the results that we get. The 4 types of data are broadly split into 2 categories. So the first 2 are individual and distribution demographic data, and the second 2 are primary and secondary behavior data. So we can now break this down and learn a bit more about what each of these categories of data that should be used to configure a search game simulation look like. So the first, in terms of individual demographic data, this is data relating to the specific characteristics of individuals or groups of individuals within a population. And how this manifests itself in a search game itself from the variables we've seen is in terms of the state of certain players, specifically gas levels. So we use data to configure the aspects of the players in our game, specifically the seeker. And what does this mean in the winter pressures model when we came to model the winter pressures environment? Well, what this manifested itself as was different SEC income levels. So we were able to use data on different SEC income levels to configure gas levels and thus accurately reflect the means of people within a given population. And the data and population we were modeling in this case was in the UK, and we used data on SEC income levels from the UK government to do this. In turn, then, once we have these SEC income levels and we combine this with existing aspects of our game, such as different strategies and payoffs, we can model then, for example, individuals with or families with children with certain conditions that have different SEC income levels. So we combine our data-driven variables, our data-driven state, with different aspects of the game that we already have to model groups of seekers or types of families. A natural development on this element of data is not just knowing the levels of characteristics, so for example, the SEC income levels of individuals, but the actual distribution of those individuals within a population. So for example, the number of individuals within a certain SEC group. So in other words, this is distribution demographic data. This is the distribution of certain characteristics within a population. This is, again, from the first point, we know the configuration of certain states in a search game, but this is now the distribution of players under those certain states within our search game. And again, like I say, in the winter pressures model, the winter pressures application, we were looking at the distribution of different SEC groups. So the number of individuals, for example, with a high socioeconomic condition that also have families with respiratory conditions. We use lots of data sets for this, mainly Elixir, which is maternity and neonatal data. This was complemented by Lambeth DataNet, LDN, and data from a study called REACH. And then finally, this gave a regional perspective specifically for London. And then we complemented this with a national perspective using more data from the UK government and data from a longitudinal study called the Millennium Cohort Study. It's natural that if we're modeling individuals in a population, we need some information about how those individuals are actually going to behave in practice. So the next aspect of data we identify as being important for a search game model that's then used for simulation is data on how individuals are likely to behave in practice. We can take this first from primary sources, and what we use this in our search game is to do distribution over things like the use of gas. And then in turn, in the winter pressure model, this will then allow us to model intervention uptake. So how likely, for example, is an individual to leverage additional gas if it's available? And in this study, for the winter pressure study, we gathered this information via questionnaires, which was part of a larger body of PPIE work, which you can see here. Again, a natural development, and for our final element of data to integrate, we can look at acquiring data on behavior from secondary sources. So in this case, in the winter pressures use case, we're looking at health utilization data, and we can see that the variable we're setting here is a payoff benchmark, which we'll talk about shortly. And again, this data was acquired from Lambeth DataNet, which is primary care data, ultimately coming from the UK's NHS. In terms of our results, what did we do now? Well, we have our now framework for configuring our model, the types of data that we need, what the model's going to look like. And so now the idea is to take this model and actually implement it, which we did in Java, building on existing work in this space that we've conducted previously. And we can then actually get these data, get these variables, and configure a simulation environment. Our first task was to actually show that we could accurately replicate the state of how things are now in our simulation model. So what we did, as referenced previously, we first ran a baseline set of simulations reflecting existing health utilization with data, again, drawn from Lambeth DataNet. And this then reflects our first bar here, which is our baseline simulation. And then what we did is we reconfigured our simulation to simulate future winter months. And these are the results that we can see here. And we can see that we are able to accurately replicate several real-world trends. This includes things like increased utilization, as you can see from the higher bars here, and again, the disparity between groups. So you can see that health utilization is much higher for lower socioeconomic condition groups, which is true in the real world. Finally, and just for validation, we removed all data from our simulation and didn't see the same trend, showing really or proving or validating the fact that this data was having the impact that we've seen. Finally, we showed the type of insight. Our next set of results show the type of insight we can gain by modeling in this way and running simulations. So we tested our different interventions in this simulated space, and our results showed that the best performing intervention was government advice. In comparison, household payments and increasing vaccination eligibility had little impact on health utilization, and little difference was seen between them. And really the fact that we only saw one high-performing intervention produces our overall interpretational result here, which is that more fundamental systemic changes are needed that kind of go beyond the interventions that we've seen in order to tackle winter health service pressures. In conclusion, we've shown the importance of using data when using search games to model a particular domain, and demonstrated this within the context of evaluating winter health service pressure interventions. It's worth noting that while we've gone some way towards bridging the gap between search game models and the real world, we still need validation here, but specifically of that winter health service pressure insight. It's also worth noting that we're not suggesting that all the parameters of a model need data to configure them, and indeed extensive data might not always be available. Future work will aim to get more data via PPIE, look at how search games can impact related domains, and finally look at the impact of data on other game theoretic models. I want to quickly acknowledge the team that have worked on this project. That's myself and others, and I specifically want to highlight the contributions of Abigail and Kian. There's some statements and acknowledgements here. And finally, you can find links to our platform available online if you want to look at the source of the model that we've used. You can find that on GitHub. If you want to look at our analysis, this is documented via Jupyter, also on GitHub. And for everything else, you can visit our homepage here for the project, digitalmimic.ai, and please feel free to get in contact if you have any questions. Thank you very much.